The Massachusetts Electrical Code, specifically 527 CMR 12.13 2A, addresses the requirement for an accessible disconnect means for all service entrance conductors located outside a building or structure. However, the code also provides an exception. This exception states that service entrance conductors entering a building or structure at or above grade level shall be permitted to have the service disconnecting means located inside the building or structure at any point within sight of the service entrance conductors or within 10 feet, which is 3.5 meters, of the point of entry. Therefore, based on the code, it is not a requirement to install a disconnect outside the building for all services. The disconnect can still be located inside the building within 10 feet of the point of entry, provided that the conditions of the exception are met. These conditions are, firstly, the conductors enter at or above grade level, and secondly, the disconnect is within sight of the conductors. In conclusion, it's permissible to install a disconnect outside the building under certain conditions, but it is not mandatory in all cases. The code does allow for the disconnect to be located inside the building within 10 feet of the point of entry, provided that the conditions of the exception are met. Let's delve into some additional details that may be helpful in understanding this requirement. Firstly, consider the definition of service entrance conductors. These are the conductors that carry electricity from the utility company's transformer to the service equipment inside a building. They are the main artery through which electrical power flows into the building's electrical system. Secondly, it's important to understand the purpose of a service disconnect. Its primary function is to provide a means to quickly and safely disconnect the building's electrical system from the utility power supply. This is essential for safety during emergencies, such as fires or electrical faults, and for performing maintenance or repairs in the electrical system. Thirdly, the requirement for an accessible disconnect means that the disconnect must be readily accessible to authorized personnel, such as electricians or emergency responders. This ensures that they can quickly shut off the power in case of an emergency. Fourthly, the exception that allows the disconnect to be located inside the building within 10 feet of the point of entry is intended to provide flexibility in situations where it may be difficult or impractical to install the disconnect outside the building. For example, in urban areas where buildings are close together, it may be challenging to find a suitable location for an outdoor disconnect. Fifthly, the condition that the conductors must enter at or above grade level is intended to ensure that the disconnect is located in a safe and accessible location. If the conductors enter below grade level, such as in a basement, it may be more difficult to access the disconnect in case of an emergency. Sixthly, the condition that the disconnect must be within sight of the service entrance conductors is intended to provide a visual reference for the location of the disconnect. This helps to ensure that authorized personnel can quickly locate the disconnect in case of an emergency. Now, let's consider some practical examples to illustrate how this code requirement applies in different situations. Firstly, imagine a single-family home with service entrance conductors entering the building above grade level. In this case, the disconnect can be located either outside the building or inside the building within 10 feet of the point of entry, as long as it is within sight of the conductors. Secondly, consider a commercial building with service entrance conductors entering the building below grade level. In this case, the disconnect would typically be required to be located outside the building, as the exception for inside placement does not apply. Thirdly, imagine a building where the service entrance conductors enter above grade level, but there is no clear line of sight between the point of entry and a potential location for the disconnect inside the building. In this case, the disconnect would typically be required to be located outside the building, as one of the conditions of the exception is not met. It's important to note that the specific requirements for service disconnects may vary depending on local interpretations of the electrical code. Therefore, it is always advisable to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable regulations. The Massachusetts Electrical Code is based on the National Electrical Code, or NEC, but it may have amendments or additions that are specific to Massachusetts. Therefore, it's crucial to refer to the Massachusetts Electrical Code directly, rather than relying solely on the NEC. Additionally, it's worth noting that the electrical code is constantly evolving to keep pace with technological advancements and safety concerns. Therefore, it's important for electricians and other professionals in the electrical industry to stay up to date on the latest code changes. This can be achieved through continuing education courses, industry publications, and participation in professional organizations. Let's also touch upon some related aspects of service disconnects, such as the types of disconnects that are commonly used. Firstly, there are fuse disconnects, which incorporate fuses to provide overcurrent protection for the electrical system. Secondly, there are non-fuse disconnects, which do not include fuses and rely on other overcurrent protection devices, such as circuit breakers, to protect the system. Thirdly, there are enclosed disconnects, which are housed in a metal or plastic enclosure to protect them from the environment and prevent accidental contact with live parts. Fourthly, there are open disconnects, which are not enclosed and are typically used in dry, indoor locations where there is less risk of environmental damage or accidental contact. The selection of the appropriate type of disconnect depends on various factors such as the size of the electrical service, the environmental conditions, and the specific requirements of the electrical code. It's also important to consider the ampacity rating of the disconnect, which is the maximum amount of current that the disconnect can safely handle. The ampacity rating must be sufficient to handle the maximum load that the electrical system is expected to carry. Furthermore, the disconnect must be properly labeled to indicate its purpose and ampacity rating. This helps to ensure that authorized personnel can easily identify the disconnect and use it safely. In addition to the location and type of disconnect, the electrical code also specifies requirements for the grounding and bonding of the disconnect. Grounding and bonding are essential for safety, as they help to prevent electrical shock and reduce the risk of fire. The grounding system provides a path for fault current to flow back to the source, which causes the overcurrent protection device to trip and energize the circuit. The bonding system connects all of the metal parts of the electrical system together, which helps to equalize the voltage and prevent dangerous voltage differences from developing. The electrical code specifies detailed requirements for the size and type of grounding and bonding conductors, as well as the methods for connecting them to the disconnect and other equipment. It's crucial to follow these requirements carefully to ensure the safety and reliability of the electrical system. In summary, the Massachusetts Electrical Code requires an accessible disconnect means for all service entrance conductors located outside a building or structure, but there is an exception that allows the disconnect to be located inside the building within 10 feet of the point of entry, provided that certain conditions are met. These conditions are that the conductors enter at or above grade level and the disconnect is within sight of the conductors. The purpose of the service disconnect is to provide a means to quickly and safely disconnect the building's electrical system from the utility power supply. The disconnect must be readily accessible to authorized personnel and must be properly grounded and bonded. The specific requirements for service disconnects may vary depending on local interpretations of the electrical code, so it is always advisable to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable regulations. It is paramount to adhere to the Massachusetts Electrical Code, ensuring a safe and compliant electrical installation. Service entrance conductors should always be handled with caution, following all safety protocols. The disconnect's accessibility and proper grounding contribute significantly to overall electrical safety. Different types of disconnects, such as fused and non-fused options, cater to diverse electrical system needs. Staying informed about evolving electrical codes is crucial for all electrical professionals. Always prioritize safety and compliance in every electrical installation and maintenance task. Consider factors like the building's construction type and location when determining the disconnect placement. The disconnect must be adequately protected from environmental factors to ensure its longevity and reliability. Regular inspections of the service disconnect are essential for identifying potential issues early on. Proper labeling of the disconnect facilitates quick identification and safe operation. Only qualified personnel should handle the installation and maintenance of service disconnect. Use appropriately rated tools and equipment when working with electrical components. Before commencing any electrical work, always verify that the power is disconnected. Follow lockout tag-out procedures to prevent accidental re-energization during maintenance. Be aware of potential arc flash hazards and take appropriate precautions. Wear personal protective equipment, including safety glasses, gloves, and arc-rated clothing. Familiarize yourself with emergency procedures and have a plan in place in case of an accident. Implement a comprehensive electrical safety program to promote a culture of safety. Regularly review and update safety procedures to reflect current best practices. Provide ongoing training to electrical personnel to enhance their knowledge and skills. Document all electrical work, including inspections, maintenance, and repairs. Maintain accurate records of electrical system components, including service disconnects. Invest in quality electrical equipment and materials to ensure long-term reliability. Consult with electrical engineers for complex electrical system designs. Work closely with local utility companies to coordinate service connections and upgrades. Adhere to all applicable building codes and regulations. Prioritize energy efficiency in electrical system designs to reduce energy consumption. Consider the environmental impact of electrical installations and choose sustainable options. Educate building occupants about electrical safety and energy conservation. Promote responsible electrical consumption to minimize waste and reduce costs. Continuously improve electrical systems to enhance safety, efficiency, and sustainability. Remember that electricity is a powerful force that must be treated with respect. By following safety precautions and adhering to electrical codes, you can help to prevent accidents and ensure the safety of yourself and others. Always seek professional guidance when dealing with electrical systems to ensure safe and efficient operation. Take the time to understand the intricacies of electrical installations and contribute to a safer electrical environment for all.